right, we are looking at our Unit 2.5 study guide, version 2, because we went over version 1 in class. So the first problem, we are given this triangle XYZ, and we are told that the cosine of x is equal to a, the sine of x is equal to b. So if you remember, the cosine of x would always be the adjacent side over the hypotenuse. The sine of x is the opposite side over the hypotenuse. So for us to just get a or b for the sine and cosine, we could think of this as like a over 1 and b over 1. I know this is a little abstract. So on my actual triangle, if I look at angle x, if the cosine is the adjacent side over the hypotenuse, then that would tell me that this segment, xy, over this hypotenuse has to be a. So I'm going to just say that the hypotenuse has a length of 1, that this side, we're going to call this a, so that now the cosine of that is a over 1, or just a, and then the opposite side we're going to call b. So that if I thought about this, the sine of x is b over 1, which is the same as just b. So now, using this information, we're going to answer these questions. The first is to find the tangent of x. And we know that tangent is opposite over adjacent. So if I look from x, my opposite side is b, my adjacent side is a. So I could call that b over a. And that's all I would write for the tangent of x. For the tangent of z, my opposite side is a, my adjacent side is b. So that would be a over b for opposite over adjacent. For the cosine of z, the cosine of angle z, we said cosine is adjacent over hypotenuse, and now we have to look at angle z. Well, the adjacent side is going to be this side we're labeling b. So that's going to be side b. The hypotenuse is 1. So we would get b over 1, which is just the same as b. Now you notice that the sine of x was also b. So the cosine of z and the sine of x are the same value. So then we're asked for the sine of z. So I go to angle z. We know sine is opposite over hypotenuse. The opposite side is a. The hypotenuse is 1. So we get a over 1, or just a. And realize that this was the same as the cosine of angle x. So it's not really a coincidence that both of those are a and both of those are b. All right, then we're asked to write the sum of the sine of z plus the cosine of x. So we already found the sine of z. We said that is a. And we were told that the cosine of x is also a. So we would get a plus a, and we could also think of that as just 2 times a. So I know this is very abstract, but hopefully it's making sense since we've done a problem like this before. Next one, we have the tangent of x minus the tangent of z. Well, we found the tangent of x is b over a. We found the tangent of z is a over b. So we could write this as b over a minus a over b. Now, if we really wanted to go nuts, we could rewrite that with a common denominator, but I'm going to say that this is really as far as we need to take this one. And then lastly, the sine of z plus the sine of x. Well, we already found the sine of z, and we said that that was a, and we were given that the sine of x was b, so we could just call that a plus b. All right, and that's all we have to do for problem 1.